Okay, so here in this problem, a rope is wrapped around a cylinder. A rope is wrapped around a cylinder. And it has a radius r and mass m. Knowing that the cylinder is released from the rest, we have to obtain the velocity of the center of the cylinder after it has moved by distance s. So since it is only asking for the velocity, so let me write so in this case we are going to need only the energy conservation equation. So first of all, let me draw this again. Okay, and on this a rope is wrapped. Okay. So after it has come down by a distance of like this, so the distance, let me call this datum. This is the distance s. It has come down by a distance s. When it is released from rest, there is the kinetic energy T1 is equals to 0 and potential energy is mgs. Here V2 will be 0 and T2 would be so when it has obtained a velocity omega. Okay, when it has obtained a velocity omega, so V can be written as r times omega. So now the kinetic energy can be written as half mv square plus half I omega square. Or you can say half mr square plus I times omega square. Okay, so this is the kinetic energy and potential energy. So now you can write from conservation of energy. So there are no other force acting on this body. Okay, since there is no external force, of course one external force is there, this is tension T, but since this the point of moment of tension T is 0, so this is a rolling motion about this point on which it is acting. So the velocity of this point is 0, so work done by this tension would be 0. Therefore you can write mgs is equals to half mr square plus I times omega. So this will provide you omega is equals to how much? I think this is the question. Velocity of the center of the cylinder has been asked, right? So once the angular velocity is known, you can obtain velocity is equals to r times omega. Okay, thank you.